In my previous video, I reviewed how to add and subtract mixed numbers. In this video, I'm going to review how to multiply and divide mixed numbers. So let's go ahead and get started. Number one, our problem right here says 7/9 times 3 6/7. Now, I've had students before they'll ask me, when they first saw this, they were kind of taken aback. They didn't realize that the dot represented multiplication, but multiplication can be represented by a dot. I have seen it on some calculators as an asterisk. I've seen it as the X. I've also seen it in form of parentheses. For instance, you might have 2, and in here you might have 8, and that would be 2 times 8 equals 16. So you can see multiplication, that operation, represented by numerous symbols, and this one just happens to be the dot. If it has another name than just that multiplication dot, I'm not aware of it. So let's go ahead and look at how to solve number 1. Now, I'm going to consider this my workspace like you would scratch paper, and I'm going to very carefully make sure that I can write my multiplication problem exactly the way it is here, because if I made a simple error just by maybe making an 8 instead of a 7 here, my answer, my product is going to be completely off. But here I have 7/9 times 3 6/7. Now, with multiplication, the rules change. It does not matter if you have like denominators or not. That does not matter at all. But the approach that I would take with multiplying fractions is I would go ahead and convert all of my mixed numbers into improper fractions. 7 times 3 is 21, and 21 plus 6 is 27. And then my denominator stays 7. Now, this is another feature that's different, I'm getting ready to show you, than with addition or subtraction, and that's where you can start your simplifying process before you even multiply anything. Now, when I first look at this, I know that I'm going to be multiplying numerator by numerator, denominator by denominator. And the prospects of multiplying 7 and 27 is not something I really want to do. It's not something I like to do mentally, and I don't want to have to write it out, and I don't want to dig out a calculator. But I'm in luck. Because of cross simplification, I can simplify these big numbers and make it a lot easier and more manageable. Let's approach set my 7 first. Here I have 7 as my numerator, and I'm going to look to see if my denominator is something that I can work with as far as simplifying, and lo and behold, it's 7 already. So I'm lucky. I can go ahead and say 7 will go into itself one time, and 7 will go into itself one time. Anytime your denominator and numerator are crosswise like this, are the same, they pretty much cancel each other out, and you're left with 1 in their place. So now, even if I had to multiply 1 by 27, that's not nothing to struggle with, because 1 being the multiplicative identity, anytime I multiply a number by 1, my product will be the number I start out with. But still, I can look at this cross area, this numerator and this denominator, and I can see that there are two numbers that will simplify with each other. Now, 9 and 27 have a greatest common factor of 9. 9 will go in itself one time, and 9 will go into 27 3 times. So now all I have to do is look at it this way. I multiply my numerator with my numerator, my denominator with my denominator. 1 times 3 is 3, and 1 times 1 is 1. And any time your numerator is over a denominator that is 1, your simplified version is going to be a whole number. For instance, 3 divided by 1, and that fraction bar is simply representing the operation of division. 3 divided by 1 is 3. So the answer for number 1, 7/9 times 3 6/7 is 3. 3 is my answer. But now I would always want my students to work out their answers on scratch paper so that I can look at it and see if they made any simple errors if it turns out their answer is wrong. Like, let's say, for instance, this 7, they wrote down an 8. Well, if this is an 8 and they go through all the process, all the steps, and they correctly come up with a factor, a product for 7/9, or 8/9 times 3/6, I'll give them some partial credit. But that's why I want them to use scratch paper to see if I can give partial credit, also to make sure they didn't get out a calculator. And in another one of my videos, I will show how students can solve these types of problems using a Texas Instrument Model 15 calculator. Now let's look at our division. With our division, we'll do number 1. We'll do number 1 together. We'll do number 1. Let me clear my board a little bit. Now division is a very interesting type of fraction problem, and it'll be fun to work this one out. 11 and 5/6, and then we have our division symbol, and 9 and 2/3. So we have 11 and 5/6 divided by 9 and 2/3. And the first thing I want to do is I'm going to have to convert these mixed numbers into improper fractions. 6 times 11 is 66, plus 5 is 71. Now what I did was I took my denominator and multiplied it by my whole number, and then the product that I achieved was added with the numerator. So 6 times my whole, 11 wholes, that would be 66, plus 5 is 71, and then my denominator stays the same. And 3 times 9 is 27, and 27 plus 2 is 29, and that's going to be over 3. Now, there's something that I need to do. Whenever you are multiplying your fractions, you need to do what we call a reciprocal. We need to take this second fraction and write down the reciprocal of it. For instance, I have 71 over 6. I'm going to put my multiplication dot now. And the reciprocal of 29 over 3, I simply flip-flop it. And I make it 3 over 29. 3 over 29. So that's how we do this. Now I'm looking to see if I can do any kind of cross simplification. I have a 71 here and I have 29 here. And I know that this and this number, they're not going to share 2, they're not going to share 3, they're not going to share 4, 5, 6, 7, 8, 9, 10. They're not going to share any factors that I can think of right off. So I'm going to assume that those two numbers are relatively prime, that the only factor they have in common is 1. I could be wrong, but I'm not going to be able to simplify those. With my 3 and my 6, though, I can simplify these. 3 is the greatest common factor of 3 and 6. 3 will go in itself 1 time, and 3 will go into 6 2 times. Now it's going to be a lot easier, more manageable to solve. 71 times 1 is 71. And 2 times 29 is going to be 58. Now what I have here is an improper fraction, and because I need to write my answer in simplest form, I'm going to have to convert this improper fraction into a mixed number. Now the process we do that is we simply divide our numerator by our denominator, and however many whole times our denominator will go in our numerator, that's how many wholes we have. Then the remainder is our new numerator, and then 58 will stay as our denominator. Our denominator does not change. Alright, I'll work that out as a division problem here, just so people can see that a little bit better. So 71 divided by 58 is going to be 1, and I meant to put that there, but that's okay. 1 times 58 is 58. And then let's do a little bit of subtraction here. 11 take away 8 is 3, 6 take away 5 is 1. So 58 went into 7/11 I'm sorry, 71, 58 went into 71 one whole time. It had 13 left over as the remainder, and then our denominator stays as 58. Now, when it comes to simplifying fractions like that, sometimes you might need to do a little bit of trial and error. Is 13 and 58, are they really simplified enough, or is there more that has to be done? I know some kids really struggle. They think it's such a big number, that 58 and 13, and surely there might be something that they would share, but it's not always the case. I mean, 13 and over 58 is simplified as far as it will go. So don't stress out if it turns out your fraction has a pretty good size numerator and denominator. It could be that they just don't have any common factors other than 1, and there you go. So this problem, 11, 5, 6 divided by 9 and 2/3 is 1 and 13 over 58. Now I do want to point one thing out. Sometimes you'll have a problem like this one here, number 4. I'm going to work this one out with you just for a minute, because notice that you have a whole number divided by 2/9. Let me clear my board. Now, I talked earlier when we did a problem, our multiplication problem here, some if you, or maybe it was another problem, but sometimes if you have a number with a 1 as a denominator, your simplified version is going to be however many is your numerator, that's how many wholes you have. So 4, I can just simply write it over 1. 4 over 1 is equivalent to 4. And I'm going to put my multiplication sign, and I'm going to make the inverse of 2/9 right now. Instead of 2/9, I'm going to flip-flop them around, make that 9 over 2. Now I can simply take out a little cross simplification here. 2 is the greatest common factor of 2 and 4. 2 will go into itself 1 time. 2 will go into 4 2 times. 2 times 9 is 18 over 1, because 1 times 1 is 1. And that simplifies down to 18. So 4 divided by 2/9 is equal to 18. I just wanted to make sure that people were aware that that 4 is equivalent to 4 over 1. Let's take a moment to look at this 10. If I wanted the inverse of 10, because it is the second fraction, I would have to get the inverse. You could think of it as 10 over 1, and the inverse of that would be 1 over 10. I hope that this video has helped clarify a few things and help students remember maybe some things that they had forgotten with this review. Thank you for watching.